Hi, welcome back. We're looking at example 2 now in our unit 8, right triangle trigonometry lesson number 2. We are going to be dealing this this example, with finding angles. We're going to be finding missing angles. So last example, we knew the angle and we were asked to find a missing side. So this time, we're going to actually know two sides of a right triangle, and they want us to find one of the angles, not the right angle, one of the other angles. So we can do that using the inverse of our trig ratio. Now, in your calculator, you'll see buttons that look like that. That's the fancy way of saying the inverse sign. I can't get it there. So there's an inverse sine, the inverse cosine, or the inverse tangent. So your calculator can find an angle if you know the sine, the cosine, or the tangent of any triangle. So basically, notes right here, they just want you to say if the sine of theta is equal to x, if you're trying to find the angle right there, if you're trying to say theta equals, then you're just going to do the inverse, sine inverse of x. Okay, so theta, you could just put it straight into your calculator. You just do the second button and the sine button, and then whatever this x is, you'll know that. Okay, same thing with the cosine. If you know the cosine is equal to something, then the theta is equal to the inverse cosine of that x right there that you found. And the last one, if you know the tangent of theta is equal to x, then theta is equal to the inverse tangent of x right there. Okay, so our calculators again are going to be the heroes of these examples. So let's look at this first one. First of all, again, always label your triangle very first. Notice that they've already marked where theta is. They're going to give you the angle that they want you to find. So I go across from it and right opposite. Across from your right angle, right hypotenuse, and that leaves the other side as the adjacent. Okay, they will give you two sides. If they're asking for an angle, they will give you two sides. So you just have to identify which two sides that they gave you. No, they gave you the adjacent and the opposite. So we are going to remember and even write it down, our SOHCAHTOA right here. And then we're going to go ahead and look for a ratio that uses the A and the O. So notice up here, our tangent uses the O and the A. So again, we just write it out exactly like that. The T stands for tangent. So the tangent of an angle. Now we don't know the angle, so I'm going to go ahead and just write that theta right there. It's equal to the opposite, which was my 8, over the adjacent, which was my 14. All right, now remember, if we know the tangent of something, of an angle is equal to x, we can find the angle using this button. So basically, you're just going to, in your calculator, type the inverse tangent or second tangent, and then just do your 8 divided by 14, 8 over 14 right there. And let's check that your calculator gives you the same answer as mine does. So second tangent, 8 divided by 14, and I have 29.7. 29.7 degrees is what theta equals right there. Okay, all right, let's try another one. Look here, they've identified theta. Theta's right there. So here's my opposite. Here's my hypotenuse. And that leaves this side to be the adjacent. Okay, so this time the two sides they've given me are the hypotenuse and the adjacent, the A and the H. So we're going to look up here and say, oh, look, there's an A and H. They belong to the ratio of the cosine. So we could say the cosine of theta is equal to A, which is 38, my adjacent 38, over the hypotenuse, which is 40. Again, in your calculator, I'll write it out one more time. So theta is going to equal the inverse cosine of that 38 divided by 40. So in our calculators here, second cosine, and then 38 divided by 40, and I get 18.2 degrees. 18.2 degrees right there is that angle. All right, let's look at two more here. Oh, if I do that, I lose my SOHCAHTOA. Okay, so over here, we're going to identify, we're going to go across from our theta here. This is my opposite. Across from your right angle is the hypotenuse. I don't even need to write the adjacent because those are the two sides that they've given us, the O and the H. Okay, so this one's going to use the sine. We're going to say that the sine of our angle is equal to, O is first, so the opposite goes on the top over the hypotenuse. All right, I'm not even going to write this out. You're just going to realize to undo the sine to say I know the sine, I'm looking for the angle. You're going to hit second sine in your calculator and then just put in 17 divided by 22. And it should be 50.6 degrees. That is my angle right there, 50.6. All right, last example here. Again, they've given us this theta, so I'm just going to label my triangle opposite, hypotenuse, and adjacent. Okay, this time it's the hypotenuse and the adjacent that they've given us. Hypotenuse and the adjacent. So again, we're going to take a look at the cosine here. We're going to say that means I can tell you that the cosine of that angle is the adjacent, which is 11, over the hypotenuse, which is 48. That way in my calculator, I'm just going to use my second cosine button, 11 divided by 48, and I get 76.8. 76.8 when we round. That is that lovely, nice angle right there. All right, that's example 2.